Hello and welcome to the fourth part of this 5-part video series where I go through the topics we're covering in this unit. So today we're looking at exercise 2H, which is using formulas. Now I'm very quickly going to go through question 3 and just how you would solve this, but where I really want to draw our attention to is in transposing formulas or rearranging formulas to get a variable that we want, and also problem-solving applications, because that's mostly where you will see this type of problem, is in problem-solving. So very quickly, we'll look at 3a just as a review for anyone who doesn't quite remember how to do this. So when we have a formula such as m is equal to f divided by a, and we're given values, so when m equals 12 and a equals 3, and we're given values, we can use substitution to place these values in where these variables are. So obviously that would mean that m is equal to 12. We don't know what f is, but we know that a is 3. And then we are asked to solve these equations and determine the value of the unknown pronumeral, in this case, what is f. And you might be able to see we can do this by multiplying both sides of the equation by 3, and that will cancel these terms here, and that will give us f is equal to 12 times 3, which is 36. And that's how you would do part A. We'll look again at part B, just as another example for you. We've got A is equal to LW when A equals 30 and L equals 6. Again, we use substitution for A and L. We know A is 30, and that is equal to 6W. I can then divide both sides by 6, and that will give me W is equal to 30 divided by 6, which is 5. And that is part B as well. What I'll do now, take a moment, have a try of part C, and come back in a second and we'll see how you did. Okay, so looking at part C, and I've just drawn out the problem here, we need to first substitute these values in, and so we can just do that via a copy-paste technique, basically. Every time I see A, I write 64, so that's uppercase A is equal to a half. We don't know what lowercase a is, but we know B is 12, and we know H is 4. Okay, so I'm actually going to combine these two coefficient terms together. So a half times 4 is just 2. So I can write that as 64 is equal to 2 outside of a plus 12. Now we could do one of two things here. We can either multiply these two inner terms by this 2, so expand the brackets, or I can actually just divide both sides by 2, and that will remove this pesky coefficient from the equation. I'm going to do that. So let's divide both sides by 2, and that will give me 32 is equal to a plus 12. And finally, we can subtract 12 from both sides. That will give me that a is equal to 20. Finally, I wanted to look at question 5 from this exercise, and this is because it gives you a very good sort of realistic application of how we'd use formulas, rearranging formulas, substituting values. So let's give it a go. So question 5 says, the formula S is equal to D divided by T, so I'm just going to write that down. S is equal to D over T, gives the speed S in kilometers per hour of a car which has travelled a distance of D kilometers in T hours. Okay, so we know, I'm going to write this information down as that. Well, we know S is speed, and I'll put in brackets kilometers per hour. We know that D is distance in kilometers, and we know T is time in hours. It's just good to have a visual sort of representation of these so I know what each of these things mean at any point in the question. Okay, so part A, let's do that. So part A says, find the speed of a car which has travelled 400 kilometers in 4.5 hours. So we know D is equal to 400 kilometers, and we know that t is equal to 4.5 hours. And I can just solve this by substitution. So I use this formula from up here. I see that the speed is equal to the distance, which is 400, divided by the time, which is 4.5, and that gives you a result of s is equal to, checking my calculator, 88.89 kilometers per hour. So that would be how you do part A. Let's look at part B now. And I know in the past few videos I've had you solve these last problems yourself, but we'll actually do this together. So for part B, we need to transpose this formula, s is equal to d over t, to make d the subject. So we'll write that down. S is equal to d over t. We want to make this d the subject, and I can do that by getting rid of this t. Well, how do we do that? Well, I can see it's being divided by t, so we do the opposite. If we multiply both sides by t, that tells us that d is equal to ts. Part 2, we want to find the distance covered if a car travels at 75 kilometers per hour for 3.8 hours. So that's s is equal to 75 kilometers per hour. I know that's speed. And we know that t is 3.8 hours. That's time. And I can just use this equation from up here to solve. So we know what d is in terms of t and s. So d is equal to t, which is 3.8, times s, which is 75. And that gives you a total of 285 kilometers. And that would be how you solve part B.